All right. Hello, everyone. How are you all? So, welcome back to this particular channel, Pradhan Academy. So, let us see. Okay. So, I hope I'm audible and visible to all of you. Please give me a thumbs up if you are able to hear my voice and see my video. Let me know so I can see your live chats. Okay. So, yeah, we are live, right? So, okay, so how are you all doing? Are you working on the strategy video? So yesterday I have posted a strategy video and discussing on how do you guys are going to prepare for the CBSE examination that is upcoming on the 8th of March, right? So if you're just following the tips and techniques that has been told in this particular videos with the strategies that I have mentioned in the particular video, then you're basically going to do well in the examination, right? So that is something we also going to work on, right? So in that particular strategy video, I discussed about that. Try to analyze your first and second day with practicing the NCERT problems, right? As well as going through the NCERT concepts and reading all the important formulas, right? Along with that, please try to make sure that you prepare a formula sheet for the same, right? So with this, I also asked you to practice some mock test, right? And along with that mock test, try to make sure that you are basically making a habit for preparing the time bound exam preparation, right? So that is all we discussed in the strategy video. So if you are someone who is new to this particular platform, if you haven't watched that video, you can definitely find that video in the channel. Okay, so if you are someone who is new, who haven't subscribed to this particular channel, please consider subscribing to this particular channel, as we are basically here to help you out with the CBSE examination. And after the CBSE examination is over, we are definitely coming out much more stronger with JEE Main series. And once JEE Main's first attempt is over, we are coming with a dedicated practice session and revision sessions for JEE Advanced. Okay, so I will be there to guide you throughout the entire journey unless and until you reach your IIT. Right, so that's what my motto is, and I want every one of you to get the best out of this lecture. So if you're someone who's new, please consider subscribing to this particular channel. If you like these videos, please consider like the video, and if you feel like there is something that we can also do further on, you can definitely comment that in the comment section. I'm always open up to all of your comments, right? So, and please make sure that you hit the bell icon so that you don't miss out any upcoming notifications. Okay, so we are going live every day, as you can see, and we are mostly going live in the evening or the afternoon sessions, and we basically going to discuss about different topics of maths. Okay, and that's how we are going to practice and prepare the entire syllabus. So as of now, I have covered with the vectors, 3D geometry, integrals, applications of integrals, differential equations, and I have also covered applications of derivative, right? So that is a lot of portion, and also I covered probability, right? So you can see almost our entire syllabus is almost covered. So today we will discuss about continuity and differentiability, right? So today's our topic is continuity and differentiability, and with this we also have one more topic to be done, that is basically functions and relations, right? Now that is also a very simple topic. Just you have to understand the basic part that I'm going to basically help you out with, right? So after that particular series is over, I'm planning out with some of the top 10 important questions that you can definitely expect for your exams, right? Also, we will be coming up with some live mock test solutions. We will be solving the mock test live with all of you, right? So stay tuned for the particular video. Don't forget to subscribe to the channel. Let's get started. So my name is Sirsha Banerjee. I will be the instructor for this particular sessions. Okay. So today our goal is basically to understand the basics of limits and continuity, understand and apply the geometrical meaning of differentiability to different sets of problems. Also, we'll try to apply the idea that we are learning from this particular thing to the concept of calculus, and with the help of LCD, we will try to understand how these topics are very crucial and important for solving any calculus problem, right? Along with that, we also discuss about techniques on solving different types of problems, and we will also discuss about the statistical analysis or statistical analysis on basically how to approach the exam pattern, or how are you going to prepare for the paper. So that is basically on from whatever I have gathered from the past year data, right? So you can just try to understand, and I will be also helping out to understand or how we will prepare for different set of problems. Right. So let's get started on this particular lecture. I'm very excited. I hope you are all excited, right? So why can't I see your excitations? Right. If you are excited, please hit the like button. Please hit the like button. If you are excited to start the video, please hit the like button. Okay. So I hope my video is clear, right? Okay. So let's start. So before we move on, we'll basically try to discuss about. So as we move along the session, we will be discussing about concepts along with the questions, right? Before we start with the topic of continuity and differentiability, you know that the entire chapter of continuity and differentiability is based on the topic of limits, right? it's very important to understand that is all based upon the concept of limits, right? It's all based upon the concept of limits, right? So what is basically about limit, right? Now, what limit is basically a concept of approaching the function of value, right? So let me briefly mention this about this. So let us say I have a particular graph of function which is defined in the xy coordinate as follows, right? So I can see this is a graph of function, right? And this is basically bounded. Now from the chapter of functions, you know that a particular function will have its domain, right? And domain will give the information about the input values of the function. So that is very crucial, right? So from the chapter of the domain, we understand this particular part, right? So this is a function definition is basically defined within a to b, right? And now let us say at any interval which is lying between a and b, I have a point x equal to c, right? I have a point x equal to c over here, which is basically in between a and b, right? Now if I want to if I want to know what if I start approaching this x equal to c from the left hand side as well as from the right hand side, right? So if I approach this x from the right hand side, I will give the notation that x tending to c positive, right? So this basically gives you the idea that it is basically we are approaching from the right side, right? And similarly, when we basically approach on the left side, we give the notation c x tending to c minus. That basically tells you that it is basically approaching from the left side, right? Now this minus and plus has nothing to do with the sign change, right? Many students will be confused, like when we basically doing about the origin, the plus sign is basically put because at the right side of the origin we are basically having positive entries, and the left side of the origin we are having negative entries. That is nothing to do with that, right? It's basically actually originated from that particular idea, but we basically try to denote the right hand side with c plus and left hand side with minus, right? That's how we denote. Now an interesting thing will occur while we are approaching. Let us see what is the value of the y while we are approaching the x towards the left side, right? Towards c from the left side. Now once we are approaching the c from the left side, we'll see that the y values are also coming closer and closer to x equal to c, right? So let us say x equal to c, the function of value. So this is basically y is equal to function of x, right? So let us say this particular function of value is equal to f of c, right? Now once we are approaching this x towards c, we see that this particular function of value is also approaching towards the value of f of c, right? And similarly, once we are approaching from right hand side x tending to c positive, then also we can see that this particular function of value is also approaching f of c. So actually, as you can see, these values are also approaching f of c, right? As we move from the left and right hand side, right? So what is the most interesting thing to observe about here is that now once we are approaching a particular value of x from the right hand side as well as from the left hand side, we find that there is a convergence in the value of y, right? So whenever there is a convergence, that is basically the f of c from the left hand side and right hand side are basically coming same, and it is basically coming same, then this is called as the existence of limit. And whatever value I'm getting while approaching the function on the left side and right side, I call them as a value of limit. And so when I approach the limit from the right side, I will call this as right hand limit, short from RHL. And when I approach the value on the left side, I will call this left hand limit, short form as LHL. Is it clear? Please let me know if this is clear or not. Please let me know if this is clear or not. Yes, hi Sardul. Hi Sardul Patel. Uh, okay, I will repeat it. I will repeat it. Don't worry. Okay, I will repeat it. So what I was basically talking about is that now I was talking that um, I was talking about that whenever I approach the value of the function from the both the sides. So you can see over here that at if I have any intermediate point in between the interval a and b, and let us call that point as c. So at x equal to c, you will have two sides, and along the two sides you can definitely approach the x, and you can definitely see that what is the value of the y. Is it converging to a particular value or not, right? Maybe let us say if I take an example something like this, let us say one particular function like this, and and the other part of the function is like this, right? So it is an open bubble over here and it is a closed bubble over here, right? So let us call this particular point as x equal to c, and this is a and this is b, right? So what we can see that as we approach the value of x equal to c from the left hand side, we see that this particular function of value is getting some function of value, let us call as y2, and this particular value let us call as y1. So what you can see that as the as x tending to c minus, the function value is tends toward y2, right? And but in the right hand case, as the x tending towards c positive, the function value is tending towards y1, right? So in this case, we are not having a convergence, right? In this case, it is not converging to a particular value. So in this case, we say that the limit does not exist. So because what is limit? Limit is basically the functional value of a particular function when we are approaching the x from the left hand side and right hand side, and similarly we call the left hand side function value as left hand limit and right hand side function value as right hand limit, right? As simple as that. Now if your LHL, if your LHL is equal to RHL, then we call that this is the criteria for existence of limit, right? Existence of limit, right? So this is a very important criteria for limit to exist, right? And now if this particular limiting value, that is RHL and LHL, are equal to the value of the function at that particular point where you are basically calculating the limit, then we call this particular entire condition, this bigger set, we call this condition as continuity condition, right? So this is basically the continuity condition, right? So we are going to solve questions on this particular topic of continuity, right? So we are going to basically equate the right hand limit, left hand limit, and equate it to the functional value at that particular point, right? As simple as that. Is this clear? Please let me know. Is this clear? Yeah, hi Sadul Thakur. Why it is not clear? Can you please tell me which part is not clear? Yeah, Sadul Thakur, can you please tell me which part is not clear? This time I was much clear, right? Please try to understand. You can definitely rewind the video. You can go back in the time because you have the technology. You can just click on the scroller, on the slide scroller, and go back in time, right? So just check out and try to understand. Okay, maybe you can reduce the speed of the video and you can try to understand. Okay, this is very simple idea, right? So limit is nothing but it is just a function of value while we are tending or approaching a particular value of a x, right? So whatever the value of y we are getting while we are approaching a value of x, that is called as limit, right? Now, so once we understand this, let us now try to understand the next points. Is that so? I am erasing this part of the solution explanation over here, right? So now, while we are solving questions, we will encounter different types of sets of limit, right? Now, one of the very important thing is to make you understand that the limits questions of 0 by 0 form or infinity by infinity forms are easily solvable by just by applying the LH rule, right? L'Hopital rule, right? But in examination, if you're going to apply the L'Hopital rule, you're definitely going to get 0 marks because you won't get marks for the solution of that, right? So what we have to basically do, we have to try to understand how we approach limits, right? So for differences of limit, we have different criteria, right? So starting with algebraic limits, starting with limits of rational types, you just have to rationalize and try to approach their answers. For algebraic limits, like you have to factorize and find the answer. So there are multiple methods. Okay. Now, if you are someone who haven't studied the chapter of limits while in class 11, I would definitely recommend you to please revisit the NCERT class 11 textbook and please come up with those part. Right. So for this part of the lecture, I am basically trying to recap the basics part of some important formula, right? So I will be trying with the trigonometric limit. So if I have the trigonometric limit like limit extending to 0 sine x upon x, now this particular value is equal to 1, right? So this is basically a 0 by 0 limit, right? And similarly limit extending to 0 tan x upon x is also equal to 1, right? But from these two cases, you have to understand a very important inequality, that is sin x is always less than x is always less than equal to is always less than tan x, right? This is a very important inequality, right? This is a very important inequality, okay? So please have it recall, okay? This is very important because it is going to be a question point for your JEE mains, okay? So this is basically true for all x belonging to domain, okay? So I'm writing D for domain. You will understand what domain basically tries to satisfy because you have tan x. So right. So you know how the tan x domain is, right? It's all the real number minus those points where you're having pi by 2 or integral or odd multiple of pi by 2, right? So these are the two important limits. Now along with that, one more important limit of trigonometric limit is basically extending to 0, 1 minus cos x divided by x square. This is also basically of the form of 0 by 0 limit, and this is also equal to minus of 1 by 2, right? So these three important trigonometric limits are very important and very crucial, right? Now along with that, we will also have to talk about some of the exponential limit, that is limit extending to 0 e to the power x minus 1 by x is also equal to 1. And similarly, if in place of this, if you put a to the power 0, so this is 0, right? So a to the power x minus 1 upon x, okay? Now this particular value is equal to natural log of a, okay? Very simple, right? And this is a 0, okay? This is 0. So it is basically go of the form 0 by 0 form, right? Now this is basically exponential limit. Now along with that, I will have to write one more important form of limit, that is basically the logarithmic limit, right? So I'm erasing this part of the writing, okay, and I'm writing the formula over here. So one more thing that you need to recall, okay, that is basically if you approach, so this is going to be your fifth. So this is basically limit x tending to 0, 1 plus natural log of x divided by x is basically equal to 1, okay. Sorry, extremely sorry. Natural log of x plus 1, okay. Now natural log of x plus 1. Otherwise, it's not a 0 by 0 form, right? So natural log of x plus 1 is basically equal to 1, right? So this is something you have to remember. And lastly, one more very important limit, that is basically 1 to the power infinity form, right? Now all this form you can see is a basically of the 0 by 0 form or infinity by infinity form, right? So one interesting way to solve infinity by infinity form questions are basically to just take the reciprocal. So if you have x tending toward infinity, so 1 upon x will tend towards 0, right? So that's how you're going to solve the question and make it a problem of 0 by 0 form. Very simple. Now, this is very important to solve questions of 1 to the power infinity form, right? So the limit x tending to 0, 1 plus function value of x whole to the power g of x, where g of x tending towards infinity and f of x tends towards 0. So this particular limit can be easily written as, right, e to the power limit x tending towards 0 f of x into g of x, okay, as simple as that. Now you just evaluate this and that is the value of the limiting answer, right? Is it clear? Is this clear? Kindly let me know. I'm waiting for your comments. Is this clear? Okay, so this is where about the basic recap of the concepts of limits, continuity, right? So basically we will apply the concepts of limit in different types of problems. So that's why I wanted to check on this, right? So this part is simple and clear enough, right? There is nothing to be like angry and going out of the lecture, okay? Just stay tuned with this particular part, okay? If you are not able to understand, I will repeat it again and again, but please try to focus and listen to the lectures first of all, okay? Very simple topics are there, okay? If you are not able to understand, you can tell me in the live chat, okay? I'm not going anywhere. You can tell me in the live chat, okay? So let's start with the very first problem, which is from the year 2024. Right. So the question says that we are provided with a function definition as, so I have a function f of x which is defined as follows, which is a multiple definition. It is basically x square plus 3 when x is not equal to 0, and it is basically equal to 1 when x equal to 0, right? So we have the functional definition of x, right? Now these types of questions are very crucial to and it is very tricky sometimes for students also, right? But I will tell you how you are going to basically clear and understand that how you are going to approach the solution, okay? So if you look at the options, you will find out in the options you have to either check for continuity plus differentiability, right? So if you look at, first of all, let us try to think in the term of continuity, right? Now if you look at the function definition, so except the value at x equal to 0, all the points, at all other points of apart from x equal to 0, we have a polynomial kind of function, right? So you know polynomial functions are always continuous and differentiable, right? So polynomial functions, so this is something very important. Polynomial functions are always continuous and differentiable. So I'm writing C for continuous and D for differentiable. Okay. But while you are writing the actual answer for your paper of your CBSE, please make sure that you write the entire thing. Okay. So polynomial functions are always continuous and differentiable for all x belonging to its domain. Okay, so d of f basically refer to the domain of that particular polynomial function. Okay, now if I have this particular criteria, but what I see that it is basically changing its definition at x equal to 1, x equal to 0. So that's why our focus of our point of interest should be at x equal to 0, right? So let us start with checking the continuity condition. Okay, continuity condition at x equal to 0. So if you look at the continuity condition at x equal to 0, let us try to find out what is the value of my limit x tending to 0 for this particular function. So while I calculate the value of limit x tending to 0, I won't directly put x equal to 0. That's what I basically mean to say. The limit is not exactly equal to x equal to 0. It is the approximate value of x of the y that you are getting while you are tending your x from the right hand side of x equal to 0 or x equal to that particular value, and from the left hand side. And if those two values are equal, then only we are going to get a finite value of limit, right? So that is a very first of a very most important misconception that many students have developed, that limit x tending to 0, that means x equal to 0. That's entirely wrong. Limit x tending to 0 does not necessarily do not mean x tending to 0. It means either x is basically equal to 0.99999, or either x equal to basically, sorry, extremely sorry. So basically it's around 0, right? Sorry. So if it is around 0, it will either be greater than 0, that is 0.0001, or it may be either less than 0, that is minus of 0. Um, what you can write? Yeah, 0.999, right? As simple as that, right? But what I basically mean to say that is basically it's not exactly equal to the value of 0, right? So once we are tending the value of x equal to 0, we do not need to equate the value x equal to 0. Rather, we will tend the value of x from the left hand and right hand side. Is it clear? Please excuse me. Basically, it's like left hand will basically, when x is basically minus of 0. Minus of 0, it is lesser than 0, right? And the right hand limit is basically like x is basically 0.00001, right? Greater than 0. As simple as that. So I will write like minus 0.0001, something like that. Okay. So this is basically clear, right? So basically we are not equal to 0, but it is basically tending the value of x from the left and right hand side, right? Now, if we just try to find out the polynomial value at x equal to 0 from this particular relation, we find out that this particular limiting value is equal to 3, right? But this particular limit exists, but if is it equal to the value of the f of 0? No, this particular thing is not equal to the value of f of 0, because at f of 0 the value is 1 and our limiting value is 3, right? So if you just try to understand the graph of the function, it is like a parabola. It's like a parabola. So at x equal to 0, it is basically 3, right? But I just put an open bubble because x equal to 0 is not included in this definition, but x equal to 0, it is basically equal to 1. So it is like this, right? So you can see there is a point discontinuity. There is a point discontinuity, right? So our definition of the point is not equal to the value of the finite limit, right? So we call this kind of discontinuity as point discontinuity. This comes under the removable type. Okay, so we can remove the discontinuity over here by equating the value of f of 0 equal to 3, right? So therefore, once I have a function which is not continuous, then that function will be never be differentiable. If a function is not continuous, then it cannot be differentiable. So first of all, check continuity, then go to differentiability. For a particle to be differential, the function must be continuous. Is this simple and clear, right? This is very simple and clear, right? So therefore, if we just look at over here, so what we can see that this particular function is discontinuous and infinitely many point. Now, why I'm calling infinitely many point is that you will see that at x tending to infinity, okay, yeah, so at x tending to infinity, you will see that its values is basically tending towards positive infinity, and similarly at x tending to plus infinity, it is also tending towards plus infinity, right? So you can just look at the graph. So it's basically discontinuous at a one particular finite point, right? So is this clear? Is this clear? Please let me know. If this is clear, please let me know. I'm watching at your comments. Please let me know if this is clear or not. So simply, if you just look at the statement, you can see that this particular word is not continuous only on one particular point, that is x equal to 0. But apart from all other points, it is basically continuous and differentiable. Hence, your answer is not discontinuous and infinitely many points, but it is basically continuous and differentiable at all points except real number minus 0, right? So apart from x equal to 0, it is always continuous and differentiable. That is what I wanted to say, because polynomial functions are always continuous and differentiable. So therefore the answer to this particular problem is going to be option number C. Okay, that's going to be option number C. Is this clear? Is this clear or not? Please let me know if this is clear or not. Okay, so I'm going through your live chats. Please let me know if this is clear or not. I hope this part is clear, right? So we got option number C as the answer, right? So if you understand this, let's get started on the next problem. And again, we have a next problem is basically you're talking on the that saying that we have a particular function which is continuous function on a closed interval a to b and differentiable on open interval a to b, right? So if this particular function is strictly increasing, so we have to discuss on the strictly increasing condition in the open interval a to b, then which of the following conditions should satisfy, right? So let us see how we basically try to prove the condition or criteria for increasing, right? So if you just have this particular problem, this is a basically a simple one marker problem. You are not going to solve it the way I'm going to do it over here, but rather what you will write it up is that I will show you. First of all, try to draw a particular function which is basically strictly increasing. So let us say that I have a function which is starting from x equal to a and is strictly increasing like this fashion. Okay, and it is basically going to x equal to b, right? I know many people know the answers to this, but for again, if you are showing one or two lines of calculation or steps, that is always a bonus point to the examiner. This will actually show you that how well have you prepared, right? So it will make you stand out as compared to your other aspirants. Okay, so let us try to analyze over here. So if you see that this particular function, so let us consider at any intermediate point x equal to c. Okay, at any intermediate point, let us call this x equal to c1. Okay, now if you just consider x equal to c1, okay, now if you look at any two interval, let us say x equal to c1, and let us say take another point on the right hand side x equal to c2. Okay, so what we can see that if c1 is basically less than c2, right? So for a strictly increasing function, the functional value should also be on the same inequality, right? So if this particular inequality exists for strictly increasing, therefore I can simply write this part. I can simply write this part as so I can write this part as f of c2 minus f of c1 is greater than 0, right? Now I can also divide this by the subtraction of this abscissa or the x point, and that should also be greater than 0 because c2 minus c1 is positive number. So this particular quantity is going to be a positive quantity, right? Now let us recall the condition of differentiability, right? So if you just recall the differentiability, and from the differentiability, if you recall the definition of differentiation, so at any point x, the derivative of a function is basically given as limit x tending to that particular. So let us call this point as x1. So limit x tending to x1, function of value of x minus function of value of x1 divided by x minus x1, right? So this is basically the definition of differentiation. So whenever we basically differentiate a function, we basically mean this particular condition, right? So therefore, if I just put a limit, let us say our c2, or let us say our c2 is basically tending towards c1, right? So if I just put a limit such that c2 is tending towards c1, so therefore I can write this particular thing simply as f dash of c1, right? And I will get this as greater than 0, right? Similarly, I can take one more point to the right hand side of c2 and let us call this c3. So what we can see, similarly I will have f dash of c2 is also greater than 0. So for all values of c basically in lying in between a to b, I will always have the differentiation of that particular intermediate point should be always greater than 0. That means for a particular function to be strictly increasing, this is very important, strictly increasing, right? Because if it is not strictly increasing, then it might be of the first fashion that it is increasing, then remaining constant and then increasing, right? So for this particular interval, I will have the derivative at that particular intermediate point as also equal to 0, right? Because it's a constant function, so we'll have derivative is equal to 0. So for strictly increasing function, it should be always greater than 0, right? It should not be greater than or equal to 0. It should be always greater than 0. No question is coming about equality. Okay, so from here we'll see that this particular answer will be option number B. So for strictly linear function, it is always greater than or equal to 0 for all x basically in between a and b. Is this clear? Please let me know in the live chat if this is clear or not. I hope you are all following up. Yes, is this clear? Is this part clear? Let me know. I hope this part of the solution is clear, right? So if this part is clear, so again you understand like how are you going to approach the 1 marker problem, right? Now with this, let's move to the next problem, which is a 2 marker problem. So in this question, we have to basically check for whether a particular function is differentiable at a given point or not, right? Now if we look at, so how are you going to basically approach the answer in the question in the actual paper? You have to first start with given function f of x is basically given as x square into mod of x, right? So x is square into mod of x. So what I will do whenever I have this kind of definition, I know that mod of x is basically equal to plus of x and minus of x based on the interval of x where it lies on, right? So I can just try to write the definition of f of x as x cube when x is greater than or equal to 0, and I can write the definition as minus of x cube when x is basically less than 0, right? Now with this I will also mention a very important thing, that is mod of x is basically equal to plus of x for x greater than or equal to 0, and it is basically equal to minus of x plus x less than 0, right? So if you are showing all this part of the calculation, again you are going to definitely going to get a half marks over here. Okay, so being an examiner, while if I am going to check your copy, I am basically looking out for all the basic part. Is your concept clear or not? And if your concept clear, I am definitely going to give you marks. Okay, I'm bound to give you marks. So that's how you're going to basically bake for your marks. So that's the presentation that actually you're going to matter. Okay, so please make sure that you are doing the calculation step by step and you're showing all the proper derivatives, okay, and different things step by step. Okay, now let us understand that what is the condition for differentiability. So for differentiability, again it's the same as differentiability is again same as that is the criteria is that the slope of the tangent from the right hand side, okay, from right side should be equal to the slope of tangent, okay, slope of tangent from left side. So you have to basically find out this criteria, that the slope of the tangent from the right side should be equal to slope of the tangent from the left side, right? So what is basically mean by the slope of the tangent? Let me write it over here. So I hope you are understanding this part. So therefore for differentiability criteria, that is basically called as RHD and LHD, right? The slope of the tangent from the right hand side is called RHD, and slope of the tangent from the left hand side is called as LHD, right? So LHD should be equal to the RHD, right? Now if you just look at the definition of LHD, it is basically equal to limit x tending towards x tending towards 0 minus, because we have to find out the differentiability as x equal to 0. So x tending to 0 minus, I'll just put f of x minus f of 0 divided by x minus 0, right? Now what is this basically 0 minus indicates that basically x is less than 0, right? So x is basically negative. So when x is negative, what is the definition of f of x? So when x is negative, the definition of f of x, and I put over here, is basically minus of x cube, right? And divided by x. So from here, I will get the answer as minus of x square. And now if I put x equal to 0, and now if I see that approximate value, while the x is almost tending towards 0, but from the left hand side, it is a very negligibly small negative number. So therefore, I'm going to get this answer as some negative value. Some negative value, right? Because x square is always positive, and negative of that is basically some negative value, but you will see that negative value is very close towards 0. So we approximate that answer as 0, right? And similarly, if you just try to calculate the RHD part will also simple, like limit x tending towards 0 positive f of x minus f of 0 divided by x minus 0. So from here, if you look at the definition of the function at x greater than 0, it is basically equal to x cube, right? So this is going to be equal to x cube by x, so which is again going to be x square, right? Now again, if you keep the value of x greater than 0 but very small quantity, then again x square is going to be much more smaller, right? So that is it. So we will also have your RHD equal to 0. Now, what you see in this problem is that your LHD and RHD are equal and they are basically equal to 0. So, therefore, the slope of the tangent at x equal to 0 is equal to 0. That is basically the condition for derivative, right? So, f dash of 0 is basically equal to 0 and this particular function is differentiable. So, that is how you are going to represent. Okay. So, hence f of x is differentiable. So, that is how you are going to end your answer and you're going to write the proof as because LHD is equal to the RHD. Okay. Okay, because LHD is equal to RHD and it is equal to 0. So that's how you're going to represent your answer in your actual paper. I hope this part of the solution is clear, right? So if you are just doing all the step-by-step calculations and you're showing up every part, then definitely you're going to get the full marks. Okay, so that's a plus 2 marker problem. Okay, so this part is clear, right? I hope this part is clear. Please let me know in the comment section if anything is not clear. Let me know in the comment section if anything is not clear. So you can just let me know. Okay, I'm just going through your chats. So keep messaging. Okay, if you're having any query, keep messaging. And if you're someone who is not watching this lecture live, then you can definitely message that questions or doubts you're having in the comment section. Okay, I will be going through all of your comments and I will come up with the answers. Okay, so don't worry on that part. Okay, now let's switch this. Let's move to the next problem. And again, we have a problem for the CBSE 2024 paper, and this was a +4 marker problem. Okay, so this is basically prove that problem, right? So how are we going to basically write these solutions? So this question is simply from the methods of differentiation, right? So if we know the formulas for differentiation, we are basically good to go with these questions, right? So if we just look at over here, how we are going to prove. So first of all, the statement should be starting with to prove, to prove the given quantity root x into dy upon dx is equal to 1 plus y to the power 4 by 4y, right? This is to be proved. So then you will start with proof, and while you are starting with proof, first of all mention your given y is basically given as square root of 10 of square root of x, right? That's what your given criteria is, right? Now let us try to first of all find the first derivative to this particular function y. So the if we try to differentiate it first, so if we look at this particular function, it's like a f of g of x or composite function, right? So why we'll basically try to differentiate this particular function using chain rule. So please write it that using chain rule. Now why I'm basically writing this part, so maybe if you are doing any step jumps, you might be getting fair advantages. Okay, so if you are not doing a step jumps, you might be getting a fair advantage in terms of the calculation. So if you are showing, since it's a proof that question, so if you are writing each and every part clearly, this will definitely give a clear idea into the mind of the examiner. Okay, so if we just try to differentiate in a chain rule, I'll get it as, so it is simply the differentiation of square root of x, that is basically 1 upon 2 square root x, but what I have in terms of x, I have tan of root x, right? So that will basically 2 square root of tan of root x multiplied with differentiation of tan of square root of x, that is going to be secant square root x divided by secant square root x, right? And now again I have to differentiate this root x, and that is going to be basically 1 upon 2 root x, right? 1 upon 2 root x, as simple, right? So if you just differentiate this is going to be 1 upon 2 root x, right? So now if you just try to understand, so this particular dy upon dx, and if I take the root x on the left hand side, it is going to be root x times of dy upon dx, which is equal to 1 upon 4. Now you can, if you look at this particular expression, this secant square, right? So I can write secant square as 1 plus tan square root x divided by square root of tan this part, right? Now, what you look at this particular part that you are having in the denominator is nothing but simply it is basically equal to y, right? And if you look at this part, it is basically this particular part can be simply written as square root of tan of square root of x whole to the power 4, right? So you will simply have this particular expression as nothing. So therefore from here you will have this particular expression simplified to as is equal to 1 plus y to the power 4 divided by 4 times of y. So you will have square root of x times of dy upon dx as equals to 1 plus x to the power 4 divided by 4y. So that is how you are basically going to approach the proof of this particular problem, right? So we will basically write it the over here, hence proof, right? Now, so please make sure that you're showing everything. So since you have written why is this, this is mentioned as given. So therefore, if you're writing the step directly over here, it won't make any problem for the examiner. So if you're doing all the steps correctly and showing your entire calculations also. Now over here, I have used one trigonometric identities. So if it is possible, please mention that secant square x is basically equal to tan square x plus 1. If you mention the trigonometric identity also, it will definitely show you that you're not missing out on any steps. Is this clear or not? Please let me know in the comment sections. Okay. Please let me know in the comment sections. Did you get it? Did you get this one? This one was pretty simple, right? It was just to prove the given conditions, right? You just differentiate, you get it. As simple as that. So, straightforward differentiation and you get the answer. Is this clear? Is this clear or not? Shall we proceed with the next problems? So we see that there are 4 problems that were asked in the and that part of differentiation, okay, and limit continuity and differentiability. Okay, so this is a not that important chapter that I would say, but it's also equally important. Okay, but you can see this is a very simple chapter. Okay, once you understand the basics, these are very good to go with chapter, right? So what are the basics part is that now for differentiability condition, your LHD should be equal to RHD. For continuity condition, your left hand limit should be equal to right hand limit should be equal to the function of value. That's the continuity condition, right? So this is all the basic part of the chapter that you basically need to understand, right? So with this, let's try some of the MCQ type question that has been asked in the many previous years. Okay, so let's start with this particular first problem over here. So we see that we have to find out that now these types of problems are very important problems that you will be giving a functional definition with multiple intervals of x. Okay, and you have to come up with a particular value of the unknown such that a particular function is continuous or differentiable or not, right? So that is basically a criteria that you need to talk about. So if you just look at this particular condition, so for first problem is basically said that you have a function which is defined as lambda times of x when x is less than or equal to pi, and it is basically equal to cos of x when x is greater than pi, right? So if you just look for the value of lambda such that it is continuous at x equal to pi, so first of all, for continuity condition, your f of that particular value, that is f of pi, should be equal to the LHL, sorry, and should be also equal to the RHL. That is, a limiting value should be equal to the function of value. So f of pi is basically equal to, it is basically equal to lambda pi, right? Because x equal to pi is basically given from this particular definition, and it is equal to the left hand right hand limit, right? So if you just look at the left hand limit of x equal to pi, it is basically equal to lambda pi. But if you look at a right hand limit of x equal to pi, it is basically equal to minus of 1, right? So therefore from here you will have a solution of lambda is basically equal to minus of 1 upon pi, right? So that's how you're going to basically get to the value of the unknown constant for lambda, that is equal to minus of 1 upon pi. Is this simple and clear? So this is the condition of continuity, right? I have already repeated that in the recap part. Okay, so from here I'll get the value of lambda as minus of 1 upon pi. Are you all getting the same answer as me? Okay, so this question is solved, right? Now, simply, if we just move on to the next problem, so it says that we have to find out again the value of the constant, right? You can see that these are the types of questions that are repeated every year. Okay, almost every year. You can see 2020 it repeated, 2017 it repeated, 2017 again it got repeated, right? So these are very simple type of problems that are basically going to come up in the exam. Okay, so if you're just preparing these problems, then you are good to go with the entire chapter. Okay, so what is the problem saying that? So I will be solving the fifth problem and I will be giving you the sixth as homework. Okay. So fifth part, the problem said that again the functional definition is mentioned as kx divided by mod of x for x less than 0, and it is equal to 3 when x is greater than or equal to 0, right? So if x is negative, then the mod of x will open up it minus of x. So you will have this redefined definition as minus of k when x is basically less than 0, and it is basically equal to 3 when x is greater than or equal to 0, right? So from these two parts, if I combine, I just need to find out that if it is continuous at x equal to 0, so if this is continuous, so if this part is continuous at x equal to 0, so your function of value at x equal to 0 should be equal to the limiting value. So 3 should be equal to the limiting value. So your RHL is equal to 3, but your LHL is equal to minus of k. So from here, you'll get the value of k is equal to minus of 3. So therefore, the unknown that you need to find out in this problem is basically equal to minus of 3. right? So the value of this k is basically equal to minus of 3, as simple as clear, right? So you can see these types of problems are very simple, and you just need to apply the simple understanding of the definition of function. And if you just apply your concepts of your understanding of definition of function, you are basically good to go with this problem, right? So I'm basically leaving this part of the problem number 6 as your homework, okay? So please try to solve this problem as your homework, and please let me know the answer you're giving in the comment section, okay? I will be looking for your comments. All right, so now with this, let's move forward, and I have some more problems as MCQ problems. You can see now I will definitely share this problem as a part of this PPT, okay, or the PDF. You will get that in the description, okay. So in the description, you will be joining the Telegram group, okay. In the Telegram group, I will be posting all these PDF materials, okay. So please make sure that you solve all these problems, okay. So I have two more homework problems for you: this 6th problem and this 14th number problem, okay. This is again the similar type of problem that was also already asked in the 2024 paper. So I'm predicting these types of problems are again going to be coming up in the 2025 paper, either of this part or either like this part, okay. Either you have to find the value of the constant as a 1 marker problem, or either will be this MCQ based problem, okay. So that is what my prediction is. So please come up with this particular answer and let me know in the comment section, okay. So this is again your homework problem, so please make sure that you solve the homework, okay. See, I'm basically explaining you the basic part that is definitely going to come up in your CBSE examinations. So you can understand that based on this, you can definitely redefine your preparation so that you're also going to be scoring the full marks, okay? Because I am basically going to come up with those part of the concepts and those part of the topics that are basically very important and very crucial for the exam. I'm not going to discuss any unnecessary things, because you know unnecessary thing will actually overcomplicate the task and the topics at this particular present moment. Rather, we just need to simplify and try to approach the answers, okay? Is it simple and clear? Please let me know. Is this simple and clear or not? Is this clear or not? I'm just going through your comment sections, okay, or chats. So if you have any questions or query, please let me know. If you have any questions or query, please let me know. I'm waiting for your live chats. Okay. So I believe you don't have any problems. Okay. So please try to solve this problem. Again, for the continuity condition, check for the LHL, RHL, and if it is equal to the function of value, then it is continuous. And for differentiability condition, you just need to check for left hand derivative is equal to the right hand derivative or not. Okay. So that's how you're going to approach it, right? Now people might be wondering that what is the basically meaning of derivative, or right hand derivative, left hand derivative is just nothing but the slope of the tangent. So if you have a curve like this, and let us say at a particular point, I want to approach what is the tangent, right? So if you just look at this particular point, so if you just try to draw the tangent from the such that the value of x is basically tending from the left hand side. So that is basically the when the value of x is less than c, so then you will have one particular tangent like this, and similarly when the value of x is greater than c, then you will have tangent like this, right? So if you just have, for example, if this particular function had a sharp edge over here, so if you just see over the sharp edge that this particular slope of the tangent and this particular slope of the tangents are not equal. So when the slope of the tangent at that particular point, while you are approaching the value of that particular point x equal to that particular point on the left hand side and on the right hand side, and they are not equal, then the limit, then the particular function is not differentiable. That's the simple notation, okay? So any slope of the tangent is basically given as dy by dx, and that is basically nothing but f dash of that particular point x equal to c, right? So this will give you the slope of the tangent. Now, but since we are defining, we are more interested into finding the magnitude, so therefore we will put the mod. But if we want to understand the sign scheme, then we don't put the mod over here. This is very simple, right? We'll use this particular concepts also in the questions of application of the derivative, right? So this is very important, okay? And similarly, the slope of the normal is basically given as 1 upon minus 1 upon dy by dx, okay? That is minus of 1 upon slope of the tangent. This all you need to understand for this particular part of the chapter. I hope this particular discussion was fruitful for understanding your parts of your entire CBSE syllabus. So with this, I am basically wrapping up this particular session. So I hope the session was clear enough to make you understand the basic parts of continuity, differentiability, and we also did some recap on the basic concepts of limits, right? So if this lecture is helpful, please consider liking this video, and if you find this channel contents are meaningful for your CBSE examinations as well as for your JEE Mains and NEET examinations, definitely consider subscribing to this particular channel. So I look forward for your ultimate and positive response in the comment section. So I will be coming up with one more sessions on functions and relations. So stay tuned for that. For that, you need to definitely subscribe to the channel. So right now, go and hit the red button over there, subscribe button over there, right? So with this, let's end our session over here. So I wish you all the